Okay, so picking up on where we left off, one of the things that we were looking at was this cranial meninges and looking at how these different layers may actually interact to or work together to be able to help position and place the brain in safe areas here. So if we dig into some of these details, then what we can see is in the cranial meninges here, if we take a cross section, and this is just basically a depiction of it right over here, let me move it over so you can see it, where we've kind of taken a cross section of the skull right here, and we can see the cerebral tissue that's underneath it. And what we can find is that, and if we look under there, what we have are the positioning of the skin, the scalp, the periosteum, the bone of the skull here, the periosteal layer, and then we get into the meningeal layer. And so and in this case, what we're curious about and what we really want to be able to focus on is the dura mater and the arachnoid and then also the pia mater. So these are all portions and some of the meninges that we have here. These help to create certain types of spaces, and I'm going to be able to just point these out here. So between the dura mater and the arachnoid mater is a subdural space, which is very, very small, and in fact isn't really present unless there's some kind of an appearance of blood flow or something along those lines. And so the breakage of different vessels can help fill into this subdural space and can be identified in some of these different types of structures. So then what we can have is that we have between the arachnoid meninges and the pia mater is a subarachnoid space. And that subarachnoid space has this the presence of the CSF flowing through it, as we described before. And then we have those villi, which then project outward, the arachnoid villi, which then project outward as we depicted before. And we were talking about from moving from here out into, in this case, we're showing the depiction of its extension into the superior sagittal sinus. So, okay, that's great. We can see these types of these components of the meninges. Then, let's take a look at what we're looking at in some closer pictures and some depictions of it. So if we look at this electron micrograph here, the really cool part about this is that we can be able to see these different structures a little bit more live, if you will. And what we're finding is that we have the dura mater up at the top here, and then we have the subarachnoid space, and you can see the positioning of the blood vessel and some of the other regions there. So if we look at a cartoon schematic of this, this helps to just illustrate a couple of things that smaller points, but ones that are still important. So we're looking at this dura mater, which is this sort of tough mother of the brain, and that encases the venous sinuses that drain the brain. So all that venous structure, including that superior sagittal sinus that we've mentioned a couple of times, is encased by this meninges known as the dura mater. This adds mechanical strength and helps it so that the brain is actually able to sustain its activity. And be resistant to different types of insults. So what we also can see in this type of depiction here is the central nervous system. Here's the positioning of arteries here within the subarachnoid space, and venous structures here in the dura mater. And we want to try to keep that kind of separation of arterial and venous types of structures there because that has some meaning clinically. So the arachnoid lining of the dura bridges over that the CNS, helping to the surface irregularities. These form these little cisterns that allow cerebral spinal fluid to flow through, and they form this barrier between the subarachnoid and the dura. The subarachnoid space then also allows CSF to flow through and be able to and over the brain surface. And then what we're finding is that this is where you find cerebral arteries and some veins as well that we can find here. And finally, we have the pia mater, which covers here, and that pia mater is the soft mother. It helps cover the central nervous system. So, when we look at this and we try to see what happens in terms of these different structures and different types of pathological conditions, and epidural hematoma is sometimes what happens when we actually there's a blow to the head, and it helps to create this subdural space in which or an epidural space, here. And in this case, we're actually looking at this kind of tearing that can happen with the arteries that are present within the meninges. And so here's an epidural space that's been created in that case. The subdural hematoma is one in which we have a blow to the head, and then we have this emergence of venous fluid flowing into that subdural space, the one that I mentioned to you before. And that tearing of that cerebral vein helps to create this. So an epidural and a subdural hematoma have completely different types of pathologies and onsets of action. So in the case of an epidural hematoma, a crack to the head that's depicted here in this case is actually giving sort of a lens-like kind of appearance to this epidural hematoma that's present here. So that's formed in this epidural space that we can see here between the dura and the skull, as we can depict in this particular micrograph. The subdural hematoma that we see in this kind of picture that's being present can be seen in this kind of picture. And these types of subdural hematomas are a lot longer in onset. Epidural hematomas are easy to identify. They happen quickly because it's arterial pressure that's creating them. But the subdural hematoma is one in which the venous tissues are moving up very slow. The venous system is providing a slow accumulation of blood and is not quite as quick. And so these can sneak up on you. Often these can appear in cases like where somebody's been riding a roller coaster consistently or has had some kind of more subtle trauma rather than a crack to the head necessarily that's broken the bone. What else can we appreciate when we look at some of these different types of meningeal tissues and these folds and so on that are important for the dura to be able to help shape and hold the brain? One of the things that we can appreciate as we look in this particular picture is that these different fossa cerebri, the false cerebelli, and the tentorum cerebelli, that help to compartmentalize different regions of the brain and create these spaces in which we actually have the tissue reside. So the false cerebri, for example, helps to split in the middle, right along the midline, the two different parts of the two different cerebral hemispheres. The tentorum cerebelli helps to separate the cerebral hemispheres from when we actually have in this lower, more posterior space where we have the cerebellum and some of the lower structures of the hindbrain. The false cerebri, false cerebelli rather, are here, and these help to separate the two lobes of the cerebellum itself. So let's take some more looks at these different types of structures in this next picture. So here, as we look from, and this is a posterior view, so we're looking at the back here, and what we can see is the superior cerebral vein that's present right along in here, and superior sagittal sinus, right along in here. The dura mater, that's on top of it. And then what we also see is that we have the occipital lobe positioned back here, and the tentorum cerebelli right here. Then, if we look ahead, what we can also see is that we can try to compare some of the other structures. We see, again, this superior sagittal sinus and how it's positioned with the false cerebri and the tentorum cerebelli. So what happens when things go wrong in these types of situations, right? When we look at this and we see, what can actually occur, what we find is that we have all kinds of situations that can arise from it. We'll have to pick that up in the next section.